We have a few more presentations to round out this morning session. We're going to stay a little bit in the technology world with our next presentation from Jia-Yun Liu, a research engineer with the California Partners for Advanced Transportation Technology, or PATH for short. Jia-Yun has over 30 years experience in systems modeling, measurement, estimation, simulation, optimization, control, and real-time implementation, as well as in vehicle and highway automation, vehicle dynamics, and intersection safety. He's going to talk to us a little bit about the truck platooning pilot deployment on the I-10 corridor. And I see you, it looks like you're already sharing and you already got your video going, so you should be set. I'll turn it over to you.
Thank you, and thank you for the organizing committee giving me opportunity to share our research project with DOT, FAWA on the truck platooning air deployment assessment phase 2 project. I'm the PI of a project. Jointly we have Bendix as project manager and Steve Shadover as senior advisor. The main points we will cover, one is the project overview, then experiment design. Since it is a safety summit, so we're going to focus on safety considerations. This is the most concern of a project. So for project goals include for better understanding the impacts of truck platooning on driver behavior, safety, energy consumption, and other traffic and public policy. For better understanding cooperative adaptive cruise control, we could CACC, or platooning for practical performance, and accelerating the deployment of a CAV, the connected automated vehicle technologies for freight movement through in-service freight hauling, and assessing the feasibility and efficiency of integrating truck platooning into fleet operations. The teams, we have Rogers Trucking as our fleet operator, then Westat focused on driver behavior, Cambridge Systematics based on a stakeholder development, and we have Cartran development research, innovation, and system information for our much funding providing to make the project happen, and also California CHP, California Highway Patrol, and a Volvo Group in North America and a headquarters in Sweden, where Bendix provided some ECU components for the Volvo trucks we're using. And we also team up with other I-10 corridors, including Arizona, New Mexico, Texas, DOTs, and law enforcement agencies. By the way, yesterday I had 2 presentations by the legal enforcement by Arizona Highway Patrol and Texas Highway Patrol. Very interesting because we're teaming with those teams for the field operational test because for the I-10 I-20 corridor, and also the California Truck Association. So this is the test road proposed to use, which is between Rancho Cucamonga, California, to Fort Worth, Texas, about 14,000 miles. Mostly rural on I-10, I-20 corridors with a few urban metro area, and the states including California, Arizona, New Mexico, and Texas, I mentioned before, mostly flat with a few mountain passes across. So the main task of project including implementation for refined cooperative adaptive control capability, basically level 1 automation, and driver can take care of the steering. On the new 4 Volvo trucks, that's VNL 470, 670 trucks, 76 trucks. And 3 trucks you use for platooning, and 1 will be used as a reference truck to consider impact like the energy and emission, so on. And perform regular testing of system performance and capability on test truck and the railroad before handing to the fleet operator for operation. Train truck drivers and conduct driver acceptance tests. The last one of the major tasks. And then recruit and train 4 cohort of truck drivers from fleet operator and partner Rogers Trucking for the operation for field operational test. And test for operation readiness prior to field test on I-10, and conduct 12 months formal test, operational test of the truck platooning on multi-state corridor, as mentioned before. So that's the main task of project. That's the critical milestones. Currently, we're still at the planning development phase. And we got the new trucks, and we're coming to the implementation. And the next stage was to drive acceptance test sometime in August, September, and operation readiness test in all states. That's October, November. Then from November 21 to October 22, we expect to conduct a field operational test and then the final report. So this is a truck we can use. That's a VNL 760 truck. It's a new model, a 2021 model. So we use most of the component on the truck. However, we're going to add some component to implement our CACC, Cooperative Depth Cruise Control. So let's from the bottom. So in the middle, we have front radar and a video camera. That's Continental commercial product already built in. Well, that's not what we added there. However, we're going to add 180 degrees fixed beam and pixel LiDAR by LiDAR as a backup, and also to enhance the cut-in/cut-out maneuvers, and also side LiDAR, also video camera to collect traffic data. We're not going to use for control. However, we're going to collect data there for later analysis as required by DOT, so that we can understand the dynamic interaction of other traffic with the platooning. Then we have an emergency switch, which is cut off between our computer and the G9039 bus. Then have a two PC1 of industrial computer for control and for data collection. And we have 23 terabyte removable SSD for all the data collection, including engineering data, driver behavior data, and so on. We have a driver vehicle interface developed by ourselves with an Volvo. And we have 2 GPS as backup for the because GPS in signal is very important for us to synchronize our truck behavior, synchronize our data, and also to determine the position of the truck in the platoon. We have dual antenna for DSRC communication between truck or V2V. For experiment design, for 12 months to cover an experiment to cover 4 range of weather conditions, focusing on fixed route, interstate highway, as mentioned before, with good road geometry conditions, including grade and flat, and route with urban and rural traffic, variety of position in platoon nodes, time gaps, driver selection on time gaps, and driving modes, including manual, ACC mode, and CACC mode. ACC stands for Adaptive Cruise Control, not cooperative. And both daytime and nighttime driving to understand the driver time gap preferences and obtaining optimal driver drowsiness, fatigue, and attentiveness to the driving related tasks. And incorporating structured questionnaire-based interviews with driver and dispatchers at the stage of driver recruitment and also during operation. So we need to understand the dispatchers, the operation logistics, how they actually operate the CACC trucks for daily operation of freight forwarding. Okay, now we come to the safety considerations. We consider safety from many aspects because we know this is very critical. As several presenters stated before, for truck, if strike on the passenger cars, it causes very serious damage and consequences. That's why we try to develop some progressive and defensive driving approach. The input including target distance, speed, and acceleration. As mentioned, we have radar, LiDAR perception, and a video camera. And then the ACC means adaptive cruise control, progressive coupling range with the distance gap. So ACC control, basically, the first truck will always be adaptive cruise control because in front there are no other platooning trucks. So our ACC is different from the manufacturer ACC. We look at beyond 150 and 200 meters. So we divided this distance into 4 zones. The first, when the target vehicle or target beyond 3 desired time gap, so the truck will be in cruise control mode. So consider the safe driving. But if a target fall within between 2 distance gap and 3 distance gap range, then the ACC will begin to engage with the target. So, but this is a progressive target. And once you get into the yellow range, that's between desired time gap and twice of desired time gap, then be more engaged. But once you get in this engaged distance, the orange and red will be more engaged, such as the cut-in, cut-out. So we have a different control strategies to progressively handle the target and cut-in vehicles following strategy for the ACC vehicle. Similar things for the CACC vehicle. I'm not going to repeat that. This is just high-level strategy here. And we actively handle the cut-in, cut-out maneuver, because this way, when we do a field test to be on freeways, we notice that this is just a very common situation. Some vehicle cutting very aggressively when a very short distance, and so on. So we have perception there in front, try to actively deal with that. Particularly during the stay of the cutting vehicles, we also have GPS distance between trucks to handle multiple vehicle cut-ins, because that's most of the situation at the on-ramps. Several vehicle cut-ins, but you don't know how many. But with based on GPS, we can decide, okay, even if some vehicle cut out, if there's still some vehicle cut-in to prevent the platooning. And we have preliminary fault detection handling, including communication, that's DSRC for our case. And we have radar video camera for perception. Then we added the fixed beam LiDAR as a backup for cutting, cut out, and also in case radar video camera of continental component have the malfunctioning there. We have fault detection of engine torque, engine brake, and service brake. This is the driver vehicle interface we developed before with Volvo back 5 years ago in FAW program project. So our design principle is try to make the display simple to reduce the distraction of the driver, but information rich and easy to use. Let me explain why. On the left side, we have 3 trucks there. This means that the platoon will contain 3 trucks. The subject truck will have a green arrow, so that's a third truck. And if there is a communication arrow logo there, it means that the third truck have communication with the front truck, for example. But if this appeared in the first truck, it means that the subject truck cannot communicate with the first truck. Okay, on the right side, you can see the on the upper part, there's a green button there on the upper right corner. So that means that the system is healthy for driver conduct ACC or CACC mode. If it's orange, it's warning, and if it's red, means driver need to take it over immediately. And in the middle, you can see the arrow towards or separate. So that means the gap increase and decrease. We have 5 time gaps for both ACC and CACC. And under this, we have a driver voice recording. So if a driver needs to report anything, for example, something situation weird or some traffic, driver feel abnormal, then driver can record the voice there and stop it as well. We have an import information button on the lower right corner. So driver need to import the driver ID. So we need to associate all the test data with particular driver because we have a driver behavior study afterwards for use of the data. And also vehicle position in the platoon. So this is a time gap we used in the previous FAW project. The ACC means the adaptive cruise control time gaps, including starting from level 1, it's 1.1 second, 1.3, 1.5, 1.7, 1.9. The ACC time gap includes 0.6, 0.9, 1.2, 1.5, and 1.8. So driver can, based on driver's comfort and confidence, can select the appropriate time gaps during operation. Besides, we have very convenient ways to activate and deactivate our ACC and CACC system. There's 3 ways. One is standard way, use the ACC stock under steering column. So the same function. If a driver can drive ACC, then the driver can drive CACC. The same principle, including on, off, resume the button. And all driver can also touch the brake pedal to stop our system. The last result is driver can press down the emergency button on the right collar of a driver seat. So all those three ways can conveniently disable our system and also resume systems during operation. The lower part we have schematic diagram shows the transition between cooperative depth cruise control CACC mode, ACC mode, and manual driving. So we under this we have a smooth logic transition between those modes. The driver at any time can choose drive any mode. Even the first truck, second, third truck driving in CACC mode or ACC mode, driver can still drive manually for middle truck. So the control system will automatically smoothly handle that. We also will adopt Smart CACC EEG standard for fatigue detection for driver. Driver basically will wear a Smart CACC. So the data recorded and passed back to cloud of the Smart CACC. And also you're going to give warning of a driver in case driver fatigue level reaching to certain threshold. We also have Jungle driver attentive monitoring system, which are inward looking at the driver video camera to monitor driver behavior. And those data be recorded for driver behavior study as well. Besides, to enhance safety, we added two coordinated braking strategies. One is driver activated coordinated braking. What this means that is the any driver in first or second truck, if the driver notices any abnormal situation and step on service brake, then the following one truck of trucks will activate it automatically in a coordinated manner because we have a DSRC communication. And so the following truck knows what's happening in front. So we tested this driver activated coordinated braking on a cross-line test truck with semi-loaded trucks, and it works really well. So we're going to implement this functionality with the further operational test new trucks. We also have fully coordinated braking with automatic braking. So we also tested those automatic braking in a same location in cross-landing with from 1.0 meter per second square to 3.5 meter per second square. That's pretty heavy braking. And this will including both service brake and engine brake. For both brake, when we do the deceleration and braking, the control system will try to regulate the distance. So during the heavy braking, the inter-truck distance will slightly increase a little bit instead of decrease and cause crash. So that's two of the functionality we can add to enhance the safety to avoid multiple vehicle collision, multiple truck collision. Of course, driver needs to pay more attention on that. Then we have the Bendix collision mitigation system there. That's a commercial product, which including frontal side collision warning, lane departure warning, and ABS, and emergency braking. The emergency braking Bendix basically is for individual vehicles. They do not consider inter-vehicle communication and other vehicle behavior. So they are going to run in the background. So as a last resort, so that's basically the enhancement of safety to avoid inter-truck platooning for operation. Okay, and another important issue is we tried to define clear operation domain for driver, because driver didn't know, okay, under which condition, okay, I can now operate automatically, and which condition will not be able to do that. So we try to define that as much as we can and train the driver. Basically, what we try to limit the operation rate between 35-65 miles per hour. And switching ACC only if the driver feel comfortable anytime, and limit to the freeway and not for on-ramp, off-ramps, and not for work zones, and limit to weather, road surface condition. For example, avoid slippery road, heavy snow and dust. Fortunately for I-10, I-20 corridor, this may not happen, but in case it happens, then we can limit on that. And a manual driver for lane changing, and arrange heavier truck in front in a platoon for better performance and also safety. And platoon indicator light will be on when in operation. We have been discussing this with California CHP and or Arizona and Texas, New Mexico, and legal enforcement duties, and what kind of light we're going to put on the truck to indicate the platoon operation, so that the CHP or legal enforcement will know that when they see such a truck driving a close distance. And also we have a driver behavior video data recording and remote monitoring driver if we wear a smart card. But we monitor the truck data and system remotely through modem, so not doing the operation. And we also limit avoided the manual advise the manual operation for long downgrade, because there's some speed limit and so on. We won't be able to know. And we training and practice before safety operation, and providing convenient driver manual during training, and determining abnormal situation in which a driver should take it over for manual control whenever that's necessary. Okay, so that's pretty much the presentation very high level. I'll be happy to answer any questions.
Great, thank you, Jiayun. So just so I understand correctly, so you're just currently kind of in the planning stages, and the actual pilot test run will be later this year?
Yes, planning and development stage. So we are actually working on the trucks, because those are new trucks purchased from Volvo. For trucks, so we're going to implement our CACC system there, and conduct a field driver acceptance test, then system readiness test before the field real field operational test. We expect to start from sometime in November this year.
Sure. Okay, that makes sense. I was kind of curious too, just in terms of a technology perspective. You know, I noticed that you're using DSRC for the connection. Do you think there'd be much of a difference, or it'd be better if you went to 5G?
Yeah, this is a very good question. I think many people are concerned about this. You know, the FCC's decision to limit the use of DSRC. We have been discussing this with many vendors and also researchers and government agencies. 5G basically for communication is good thing, could be faster and so on. One thing we feel be worried is the vehicle-to-vehicle communication, because it's safety critical, need to be dedicated. Current DSRC is for this purpose because it's low, small packet. Usually the communication packet we send between trucks is less than 200 byte. 200 byte, that's 0.2 megabyte. But this need to be fast, at least 10 hertz or even faster, like 20, 30 hertz, because it's safety critical. But if you use 5G, if 5G have a dedicated channel for this purpose, other people difficult hacking, not be desirable. Otherwise, we have some concerns about using 5G. If you mix the data with the other internet data, for example, on the vehicle and the passenger try to download the video data, for example, on the truck, on the passenger car trucks, then at the same time they try to use V2V, then this may cause some delay and conflict, which may cause some serious concern for safety. So that's our point of view. Thank you.
Exactly. Thank you. Thank you for that elaboration. Dustin, do we have any questions online?
Yes. Regarding the driver alertness monitoring system, what is the threshold to classify the driver as reaching the maximum level of fatigue before needing a break to resume driving again?
Yeah, this is a good question. We have been talking with vendors. Those vendors actually in Israel actually. Through smart car, through Westart actually 2 person particularly work on this. They would not provide the threshold because this is related to many factors. So they said that they have some trained some threshold, can decide okay at which level they're going to give driver warning. So what we could do is just restrict that, and then they will not even share the raw data with us. They consider that as a proprietary information. What we could do is just accept the warning and possibly disable, or in some level disable control system. But they will not even give us real-time data. So it's difficult for us to explain that. They said that this is based on their long time, many years driver behavior study.
And also, is this system monitoring by eye closure for long haul drivers?
Yes, for the jungle system, yes. The EEG system, not smart cups, where driver wear hat. The jungle system, yes. Monitor driver eye closeness, yes. Attentiveness, and if driver is facing the front or looking at somewhere else. The jungle system, yes, is doing that as well.
Thanks again. Dustin, was there anything else?
All I have.
Great, thank you. Do we have any questions here in the room? All right, we definitely look forward to the results from the field test, Xiaoyun. Thanks again.
Thank you. Thank you, everyone.